Hi, we've now reached the next video, Object Tracking Using Background Subtraction. In the previous video, we tracked objects using color spaces. In this video, we will first understand how background subtraction is better than frame differencing, and then we will demonstrate tracking using background subtraction. Background subtraction is a technique that models the background in a given video, and then uses that model to detect moving objects. This technique is used a lot in video compression as well as video surveillance. It performs really well where we have to detect moving objects within a static scene. The algorithm basically works by detecting the background, building a model for it, and then subtracting it from the current frame to obtain the foreground. This foreground corresponds to moving objects. One of the main steps here is to build a model of the background. It is not the same as frame differencing because we're not differencing successive frames. We are actually modeling the background and updating it in real time, which makes it an adaptive algorithm that can adjust to a moving baseline. That is why it performs much better than frame differencing. Let's start. Create a new Python file and import these packages. Define a function to grab the current frame. Then we will resize the frame and return it. Define the main function and initialize the video capture object. After that, define the background subtractor object. Define the history and the learning rate. Then, iterate indefinitely until the user presses the escape key. Start by grabbing the current frame, and then compute the mask using the background subtractor object defined earlier. Convert the mask from grayscale to RGB. Display the input and output images. And lastly, we check if the user pressed the escape key. If so, exit the loop using break. Once you exit the loop, make sure you release the video capture object and close all the windows properly with this line. Let's run the code file. If you run the code, you will see a window displaying the live output. If you move around, you will partially see yourself. Once you stop moving around, it will start fading because you are now part of the background. The algorithm will consider you a part of the background and start updating the model accordingly. As you remain still, it will continue to fade. It's black now. The process of fading indicates that the current scene is becoming part of the background model. And there I am, gone, almost. So, object tracking was fun. Now in the next video, we will build an interactive object tracker using cam shift algorithm.